Now we're going to find the recursive and explicit equations of quadratic sequences. Please take a look at this table to my left. Here we have x and f of x. I want you to notice that we are not dealing with f of n where n equals a term. We're now using f of x where x is a value. And the sequence is going to be for the f of x value or the y value. So here we have a value x, 0, 1, 0, 1, and 2. And these are the values that we're going to put into an equation. And when we put it into the equation, we're going to get the f of x, or the y values, which are 4, 6, 14, and 28. But just keep in mind that these are not terms, that these are the actual values of x. Now, what we're going to do is take this table, and we're going to see if we can find a constant. And we can notice right away that we're not going to have a geometric constant. There's no number that we can multiply by constant number. We can multiply 4 to get 6, 6 to get 14, and 14 to get 28. It's not going to be the same. So what we're going to do, we're going to see if we can find the difference of this f of x value by an addition constant. So when we go from 4 to 6, we get 2. When we go from 6 to 14, we get 8. And when we go from 14 to 28, we get 14. We said, what can we add to 4 to get 6, which is 2? What can we add to 6 to get 14, and it's 8? And what can we add to 14 to get 28, and it's going to be 14? And notice that there is no constant value. But if you look carefully, you'll see, well, there may not be a constant value here, but it looks like there's one here. Let's see. What can we add to 2 to get 8, and it's going to be 6? What can we add to 8 and get 14, and it's going to be 6? So we see that we have a constant value here with our second difference. So if we have a constant value with our second difference, that means our first difference is going to be linear. So once again, in order to do this, we first look for the f of x difference, which gives us these numbers, or our first difference. And then we try a second time to see if we can get a constant number that we add every time, since we didn't get one with our first difference. And sure enough, in this case, we got 6. So in order to find our recursive rate, what we're going to do is we know that we're going to get f of x minus 1. So in other words, we're going to get that value that is going to be less than 1. That's the recursive aspect. But then we have to have this rate of change that's going to be linear. So what we're going to do is we're going to set f at 1, not the first term, but the value 1. And that's going to give us 6 times x, and our x is 1, plus some number to give us 8. So we're not going to use this column here because it's linear. We're going to use this column here. So we're going to multiply 6 times 1 and see what we can do to get the value 8. This is our constant. So 6 times 1 plus some number is 8. 6 times 1 is 6. So what can we add to 6 to get 8? And we see it's going to be 2. Now let's check it again with our value 2. Our f at 2 value. Well, that's going to give us 6 times 2 is going to give us our linear answer, which is 14. So, and that's 6 times 2 plus some number is going to give us our linear answer of 14. So we get 6 times 2 plus some number gives us 14. And 6 times 2 is 12. And what number do we add to 12 to get 14? It's going to be 2. So notice we got the same rate of change. So our answer is going to be f of x minus 1, that's our previous term, plus 6x plus 2. So you're going to say 6x plus one of these terms, and you're going to add 2 in order to get our linear term here. Now, to get our explicit term, it's a little bit easier. Notice that our f of x quadratic equation in standard form is ax squared plus bx plus c, which means that we need some value a, x squared, plus some value b times x plus some value c. Now, to get these values, it's really not that difficult. This is fairly easy. To get the value for a, we take 1/2 of our second difference. So that's going to be 1/2 of our second difference is 6. That's our constant. And 1/2 of 6 equals 3. So that's going to be our a value. To get our b value, we're going to come back in just a little bit, but we're going to switch to c. In order to get our c value, what we do is we take f at 0 and see what that value is. And we're going to take, that's the f of x value that we're looking for. So whenever x is 0, notice that our f of x value is 6. So that is our c value, and we're going to put that right there. That's our c value. And lastly, coming back to b, we know that f of 1 is going to equal a plus b plus c. So what is f at value 1? We look up here and we see that our f of x value at 1 is 14. So we're going to put 14 equals a, we said was 3, plus b, which we're trying to find, plus c, which is 6, which gives us 14 equals 3 plus 6 is 9, plus b. And what do we add to 9 to get 14? It's going to be 5. We can also get that by adding a negative 9 to both sides, and we get 5 equals b. And so 5 goes there for that value. And that's our answer. F of x, this is our explicit equation, is going to be 3x squared plus 5x plus 6. And so that, as you see, is very easy. Let's do one more example. All right, here are our values for x. And remember, this is x, and this is going to be the value for f of x for our quadratic equation. And remember that we're going to be looking at the sequence under y, or f of x. And this is going to be our x, and it's not going to be a term, but the actual value. So let's get our first difference first. Okay, we know we're not going to use these two columns. All right, what do we add to negative 3 to get negative 2? And it's going to be 1. And what do we add to negative 2 to get 3? And it's going to be positive 5. What do we add to 3 to get 12? And it's going to be 9. What do we add to 12 to get 25? And it's going to be 13. And what do we add to 25 to get 42? And it's going to be 17. So on its face, we do not see a constant value. We just see some numbers. But let's see what happens when we look at our second difference. So we're not going to need this row, this part right here. All right, to go from 1 to 5, we're going to add 4. To go from 5 to 9, we're going to add 4. 9 to 13, we add 4. And 13 to 17, we're going to add 4. So as you can see, our constant is that we are adding 4. So that tells us that this section is linear. This column is linear. And it tells us that this is our constant. Now let's write our recursive value. We know our recursive value is always going to be f at x minus 1. That's going to be our previous value. Plus, we're going to add our constant times x. So that's 4x. And it's plus some number. And it's going to give us our linear value. So let's take a look at f at 1. F at 1 is going to be 4 times 1 plus some number. It's going to give us our linear value, which is 9. Equals 9. So that gives us 4 plus some number gives us 9. and that's going to be 5. Let's check with another number. Let's check with f of 2. So f of 2 is going to give us 4 times 2 plus some number, and f of 2 for our linear value is going to give us 13. And 4 times 2 is 8, and 8 plus some number gives us 13, and that's going to be 5. So notice that the number that we add to our 4x is going to be 5. And that's going to be our recursive equation. F of x is going to be our previous term plus 4x plus 5. Now, let me go through that again. So we're going to get 4 times 1, our value 1, plus some number gives us 9, which is our linear answer. And 4 times 1 is 4. And what do we add to 4 to get 9? It's going to be 5. And then we check with f of 2. So f of 2 equals 4 times 2 plus some number. And we're going to get our linear answer, which is 13. 4 times 2 is 8. 8 plus 1, what number gives us 13? And it's 5. So we get the same answer, which shows us that our rate of change is going to be 4x plus 5. And this tells us what happens in each case from one value of x to the next. Now, to get our explicit equation, we're going to use what we used before, 3 steps. To get our a value, it is going to be 1/2 of our second difference. And our second difference over here is 4, and 1/2 of 4 is going to give us 2. So I'm going to put a 2 right here where my a value goes. Then we're going to skip b and come over here to c. And our c value is where we have f at 0. And if we look on our chart, we see the f at 0 and f at x is going to be 3. So we're going to put a 3 right here for our value of c, and it also goes right here in our equation. And lastly, to get b, we use f of 1, and that's going to be equal to a plus b plus the c value. F at 1, as you can see on the f of x chart, is going to be 12. So 12 is going to equal a is 2 plus b plus c is 3, which gives us 12 equals 5 plus b, and if we add a -5 to both sides, we get 7 equals b. So we're going to put our 7 right here where the b belongs. So as you see, for the recursive value, we're going to look at our x value and our linear values. For our explicit values, we look at our x values and our f of x values. And that is how you get the recursive and the explicit equations for quadratic equations, for quadratic sequences. Thank you.